Hi. Today we have Simon Thompson with us. Simon has had a stunning career in consulting. He has completed a PhD in machine learning. He is a BT veteran and has headed the big data and customer experience practice, and also been a principal investigator of AI as well. He's now at GFT as the head of data science. GFT provides technology consultancy services across many different business functions, including data analytics, AI, blockchain, and cloud computing. Would you like to add anything about yourself?
No, that sums it up, I think.
Uh,
Well, do you
yeah,
want me
and
to do you want me to tell you about
for
what I've been
any,
up to recently?
yeah, why not? That would be fantastic.
Okay, so I guess the most recent interesting thing I've done relevant to this podcast is write a book called Managing Machine Learning Projects, and that's currently available on early access on the Manning website. Manning are my publishers, and it'll be released on Amazon on the 5th of August. So please buy it.
Yeah, and I have no doubt it's an amazing book. And yeah, so hopefully, uh, do try to read that. And I think it is specifically for data, sort of data projects, right? It's about the actual project management of a sort of a data project. Is that
Well,
correct?
really a machine learning project. And the difference is that with machine learning, you're building models and you're essentially you're letting the machine find a model in data. And there are two things about that. One is that you have to set up the infrastructure and mechanism by which that can happen effectively and make it repeatable and high integrity. But the other thing that's important is that there's a lot of risk in that until you get going, it's very hard to know what models the machine is going to find and how good they're going to be and what their particular properties are. And a lot of the machine learning project is all around trying to remove the risk that the modeling phase is going to fail and to make sure that the results that are produced really are consumable in an actual valuable business process. And that's really what the book focuses on is the actions that you've got to take to deal with these risks and to therefore get artifacts out of the project which are valuable to your customers.
Okay. Um, that is incredibly interesting. And could you, uh, since you've had such an interesting career, could you tell me a bit about one of the biggest challenges you've had in your career in terms of AI and machine learning?
Um, Gosh, that's a very good one. So, um, well, I think always the challenges come from two directions. One direction is the when you're faced with a problem of very large scale, and you have to deal with very large scale data resources and very uh, challenging implementation platforms which get in the way of delivery. And certainly, working in the early days of big data, I faced quite a few challenges like that, where the data processing systems really created a big barrier between us and creating value. And in fact, I still see that in projects now, and I don't want to name names, but we still have projects where we come across software infrastructures which are very difficult to use for all sorts of reasons, just investment reasons, but also security and regulatory reasons as well. And these very hard to use systems have to have to be employed to create value, and it really does slow things down and make things difficult. The other thing that I've seen a lot is problems to do with a disconnection between the business requirements and the technical possibilities. And there's a very good project example, which I can talk about now because it's so long ago. And I know all the people have moved on, basically. There's a project at BT called Project Neem. And this was about using a handheld gaming console, an early handheld gaming console, to provide a communication layer. And this was all demonstrated that there was some hacking had gone on. People had found out how to do this, and the the telecoms infrastructure, the Wi-Fi infrastructure, could be connected securely and easily into these handsets. And on the other side, the handset manufacturer was very keen to get involved to make this happen. And so this really exciting looking project was created where there was going to be a voice comms layer on the gaming console, and there could be sort of like TeamSpeak type chats would be going on. And it was very enthusiastically received when it was described to people, and it was seen as a very investable project, and there was a lot of excitement. But what had been misunderstood was the fact that the console simply couldn't perform multitasking. And that meant that while you could run a voice channel on it, that would be literally the only thing it would do. So you literally had to turn it into the voice channel only system. And there were all sorts of problems to do with actually phoning the thing or connecting the thing to a chat caused by this. And nobody in the project concealed this. It was well known. It was frequently explained, but the senior management involved simply didn't understand it, and they invested in something that they thought had one set of capabilities when it didn't. And the project ran for a long time and spent a lot of money and produced nothing in the end of value anyway. A few demos and a bit of chat, but it really could never have worked. And that taught me the need to really connect connect the reality of technology to the needs of people. Because there's this guy Richard Feynman who said, you can't, PR won't work forever. I think he said, PR won't trump reality. It won't trump physics. And it's absolutely true. So yeah, that would definitely be one of the biggest challenges and problems I've ever faced dealing with that project.
Very, very interesting. And for those who haven't kind of realized, this podcast will focus mainly on AI. And it will also touch upon emerging technologies and ask a bit about sort of how these different new technologies can impact hacking, or even if ChatGPT can have an impact on things like that. Um, so so in terms of you've already sort of touched upon on sort of how these different kind of projects, and sometimes there's that um, mismatch in how technologies are communicated and the capabilities, etc. So now this was a very specific case, but what are some of the general um, bottlenecks or mistakes that are often made in machine learning projects?
And not reading my book, that would be a key one. You definitely need to read my book. I would say it's definitely in the forming the agreement and understanding the requirements phase. There's often a big mismatch there. And often these things are driven for a good reason that's very hard to get over, which is that people want the project to start and to start delivering. And if you don't get the project delivering, if you don't get moving, then you lose your opportunity. And so there's a real enthusiasm to get going and to miss out on some of the processes that are required to make things successful. And there's no real way around that. That's kind of something you just have to deal with. But whenever you can, you need to do the things that allow your team to understand properly the business challenges in front of it. So understanding the organizational structure that you're working to, talking to the users, really getting into the data and understanding the data resources, the IT resources, the ethical implications, the privacy and data protection implications, all of these things, and the documentation requirements and the testing requirements as well. These are massive things that tend to get lost in the urge to produce a result, to produce something that looks like it's going to work, a minimal viable product. And minimal viable, as I say, you have to do this kind of thing because it's what allows the money to flow. But minimal viable products will never ever create real value, because they just can't stick to the wall. They just can't sustain themselves, and all of the effort around sustaining them has to go in at some point. And the longer you work in a project without that happening, the worse it's going to be when it does have to happen, and the bigger barrier to success it's going to be. And many projects, I think there's a lot of frustration that when people discover the cost of really deploying it and really implementing it far too late in the day, and the cost is far too high, and the whole project just becomes a bust very easily. So that to me is the big mistake. Is yes, there is this need for pragmatism, but you do have to temper that with the knowledge that unless you do the hard things, the boring things that are required to make a product sustainable, you just won't be able to deliver something that's actually valuable.
Actually, this is so interesting because I remember when I was getting trained in a traineeship for about 6 months, we were actually taught, to go through the user stories and then coming up with the user requirements and then coming up with a product backlog and then conducting the risk assessment and then starting to create something, right? And I remember in that traineeship, most people would spend almost no time at the first aspects, right? With the user stories and user requirements and all of that. And they would do their best to just skip to coding. And actually, that urge is just there in every coder that was there. They just wanted
Mm,
to get to get to
mm,
the point where they were coding. But actually, ironically, when you spend more time on the initial phases, you were more efficient in the later phases. That's what I noticed. And so by not acting on your urge to actually get things done and actually following that process, you actually end up with a much better product. And that was a very interesting sort of result that I ended up observing that
yeah,
I had myself. Yeah,
I
as
mean,
well.
it is true. It is definitely true, but it is an ideal world thing, because on the other hand, there are a lot of projects where things get stopped because the business just can't see the value after a short period of time. And um, what you need to do is to balance this. There's the requirement to show some progress and show things are working, are interesting. is value to be had here, right? And you do need to balance that against the hard yards of properly understanding what needs to be done. And it's different for each project, and you need to develop the wisdom to make those choices. I would always lean on the side that you're talking to, which is to try and really do the hard yards up front and look at the user stories if there are any, or try and create user stories, which is a more common requirement that actually you'll find that user stories that are there are inadequate or just non-existent, and people have got not a very clear idea often of exactly what they want doing. And even if they do, often they don't have a clear idea of all of the actual peripheral activities that need to happen to make the thing work properly. And as I say, the reason to do that is because you can then manage the scope of the project and control the sticker shock that the customer's going to get when they actually find out how much it's going to cost to do the thing for real. Whereas if you rush in, you can end up in a situation where it's genuinely unmanageable to deploy the thing, and the cost is overwhelming. But on the other hand, as I say, if the business doesn't see value reasonably quickly, they'll often shut you down. So you have to be able to manage that. And one of the ways to manage it is to persuade the business that you know what you're doing and they shouldn't shut you down. Another way to do it is to compromise and to be able to show them, demonstrate value at the right time, and understand that that is going to impact you and is going to slow you down later.
I would now like to transition to some some different questions about sort of AI and emerging technologies. Um, so I've been reading a bit about things like 6G and terahertz communications, Internet of Nano Things. So, so how do you think this is going to be utilized in these very sort of breaking, cutting edge technology?
Well, we'll have to see, because 5G has been a bust, right? I think people in the telecoms industry will tell you actually the value of 5G has been around making all their networks more efficient and getting more out of their networks. But it's a very below the line type of value they're seeing. What they saw with 4G and 3G before it was above the line customer excitement, consumer differentiation, and uptake of new handsets and people coming on their network with new applications. I don't think any of that has happened with 5G. Precious little happened with 4G, to be honest, but I don't think anything has happened with 5G really. Definitely, it's helped route traffic around the network better, but not not apart from that, as far as I can see. And the applications that were talked about for 5G were boneheadedly stupid. Right, we should be clear. When people are talking about robot surgeons and autonomous vehicles and things like this was just science fiction 10, 15 years ago when 5G was mooted, right? And now it's coming to reality, but it's not using that technology. Basically, it's being done in other ways. Okay, so now the industry wants to move on to 6G, and again, there are always good reasons for that, and terahertz communications are good reasons for that. But are they mainstream applications? It really remains to be seen. There is a big use for AI and ML in this world, I think, which is that ML can be used as a very powerful compression system, and we now see a lot more ubiquitous, cheap compute out there, which allows ML to be deployed as a compression system or in compression systems. And so I expect that ML will play a big role in future telecoms networks. But whether it'll be deployed in a thing that's called 6G and how successful that will be, and I don't know, because again, the telecoms industry around the world doesn't have much money now. It's very much a commoditized business now, and I think it will be a big challenge for them to find the massive investment that's required to deliver a completely revolutionary new network in the future.
That's very interesting. And so, what sort of now I'm going a bit technical. What is this compression used for? As somebody who doesn't know a lot about terahertz communication.
Well, I think I'm not sure how much it'd be used for terahertz communications. I'm no expert in 6G or terahertz, but in future comms, I think there is a role for ML in compression where basically you can fill in missing information by using a machine learning approach to replace to predict what different parts of an image or video stream should look like, and basically, for things, especially things like football matches, um, you can do a lot by using these techniques. And you might notice when you watch a football match on the big screen, often on your big TV, you might notice that the ball is sometimes quite hazy and fuzzy. And there are lots of technical reasons why that might be, but one of them is because of the compression systems that are used to encode and transmit and decode very large TV images. Essentially, it's streaming 4K on your TV. You're probably using, just hundreds of kilobits per second to do that in reality. Now, that's because things are very compressed, right? The actual images uncompressed would be the video stream would be much, much bigger, but the cost of transmitting that and distributing it is too high to do it, or at least consumers don't notice or don't complain so much when you do it with compression, and you can save a lot of cost. Now, by using machine learning, I think it's clear to me anyway that I'm pretty sure that there are many labs around the world who are doing this now. But when I was looking at it, that you could do a lot to improve the quality of the images that are transmitted without increasing the bit stream so much at the cost of doing more processing when you encoded the image and more processing when you decoded it. But the devices on the edges of the network are much better now, and there's a big opportunity to do that. So I would expect in years to come that will become a very widespread approach. And also we see things like in video conferencing, the opportunity to um, uh, present machine generated simulacra of humans in situations where there's only a very narrow communications pipe. And so you can send very sparse amounts of data that says, okay, this is here's what Simon normally looks like. Here is Simon's pose and lighting and the voice stream or parts of the voice stream. And with that information and the narrow band stream, you can reconstruct a high fidelity version of me talking to you. And it isn't reality, but it's probably more relatable than it would be if it was just a black screen or some text, really. So that there's an opportunity to improve the experience of communications by using it.
Yeah, very, very interesting. And do you think there will be any impact of AI on Internet of Nano things or Internet of Bio Nano things? So I
I have
uh,
no clue. I have no clue
okay,
at all.
okay,
I don't
okay,
know.
yeah,
I don't know about those things at all, I'm afraid. It sounds very interesting, but
yeah.
again, I think especially the internet of bio nano things sounds very scary to me. It's something I wouldn't be very keen to get involved with because I have a feeling that it might end with me dissolving. So yeah, not very
Well,
keen.
the idea, or one of the things I read was that they wanted to create sort of these nanobots that could go inside a human and kill cancer cells. But yes, it is incredibly scary in terms of how it could potentially be used negatively. So,
Yeah,
yeah,
and I think even I mean one of the things that the recent stuff with AI has shown me is you have to think about who technologies can harm and who do they harm when they work as intended, who do they harm when they don't work as intended, and I think look, I think this is a time when all technologists have to consider that carefully all the time in their work. And I think that there's a lot of valorization of moving fast and breaking things, um, and I think that's fine so long as you don't end up with societal level consequences or large scale consequences because we can even underwrite appalling things like murder in terms of personal punishment, right? That if you murdered somebody, okay, you would go to jail for the rest of your life and be punished for that, right? Um, some people might even say, okay, we can execute you, and that would be a suitable punishment. Um, but then if you destroy the lives of the population of a country, or a people, if you go and do a genocide, something like that, or I did, there's no there's no accountability possible. It's out of proportion to our humanity. And when we look at what's happened with, for instance, Facebook, and I'm not saying Facebook is genocidal, but if we look at the impact that Facebook has had on our society, it does seem to me that that is disproportionate to the accountability of the people involved, that they can't really be genuinely held to account for the impact, that negative impact that tool has had on a lot of people's lives. And so, we'll have to understand that and have some humility, right?
that is incredibly interesting. So, one of the things that I really noted was that you just talked about intended and unintended, potential harm. And I think that's an aspect that people really, the unintended harm is what a lot of people just forget about. And I think that is something, especially with these new technologies like Neuralink and others,
Yeah.
and this Internet of Bio-nano things, th- that is where I am also starting to get a bit, you know, scared a bit, especially with the Neuralink one. Like if your brain is connected to the internet, or if there's an electric charge that's going through your brain, and what if they were to increase it, or you know they could hack that device, and if it's connected to the internet, so the
Well,
potential
or
for harm is incredible. Yeah.
yeah, or what if just in its normal functioning, it drove you to despair to the point that you ended up hurting other people. Now, whose fault is that, right? And if that kind of technology were to affect a large number of people, how can we make that good again, right? So I think as computer scientists, we were very innocent, um, because our technology uh, didn't have very huge impacts until the 1990s, really. And it was very controllable. and very marginal. And then we got the internet, and we got social media, and we didn't know what was going to happen. Really, we thought it was going to be okay. We thought it was going to be great, and then it went wrong. It's gone wrong in a lot of ways, and it wasn't really our fault. But what we can't do for sure is claim innocence from now on, right? We have to be aware of the potential for harm that the technologies we trade in have.
That is very interesting. And that actually brings me perfectly to the next question, which is AI's impact on. I wanted to ask about spacecrafts, but I think we can leave that for later. But on hacking, right? Because
Mm,
I have met sort of professional intelligence agency hackers who have told me, that there's so many things that can
yeah,
already be hacked, and
yeah.
the public doesn't realize it. Um, so one of the things I was, for example, told was an encryption key, which is considered to be incredibly safe, can actually be hacked, and they have these sort of they can spin up these sort of cloud VMs, and then they can run through all the iterations and then actually hack the communication through it. Now, I wanted to ask you, what do you think the increase in compute power, you just noted that the sophistication of the ML algorithms is now increasing as well. What kind of impact do you think it will have on hacking and cybersecurity?
Well, um, it's always something it's got to be a little bit cautious about commenting on, because there are techniques uh, that are obvious if you're versed in the state of the arts, if you know some of the maths, that are relied on to um, maintain security. Um, but I think it is reasonable to say that the new wave of AI tools is going to have a massive impact on our personal use of the internet and communications technology, and it's going to be very difficult to determine if a communication is fraudulent or real. Um, there's going to have to be a lot of work, and I know a lot of people are doing a lot of work around trying to provide secured channels um, that people can rely on, that people can trust. I think most of the channels of communication that we use, the trust is fraying. So, you can't trust anything that comes through your email anymore. For instance, I got a spam scam email about my TV license the other day that was pretty good in that it made me jump, but the wording was a little bit poor. It doesn't take much imagination uh, to see that if you use one of the new large language models, you could construct a really good spam email that would be much more deceptive very easily and very cheaply. Um, and then, we were talking about using ML, generative AI in communications. Um, it's very easy to see how it could be used to fraudulently create voice calls, video calls to scam vulnerable people. So I think that these kind of tools are going to be used very heavily in social engineering. Um, and I think that there's going to have to be a lot of work to rebuild trusted channels for information. We're going to see a huge impact on the material on the internet that we can trust. I think I tried out Bard this morning from Google, and the first thing it did was it gave me an incorrect answer to a programming question, and it looked good, but then I tried it and it was wrong. And that that material can get onto the internet, will be getting onto the internet, and Google search is going to be very corrupted by this. I mean, it's already quite corrupted by a whole load of scam sites. I think Google is going to struggle, and I think all the search engine providers are going to struggle to keep up with the disinformation and the corruption of the information that's out there. And it's there's somebody, Rod Brooks, wrote a blog recently, and he said, the only trusted resource is going to be Wikipedia, basically, because it's all human edited. And can Wikipedia maintain its integrity? This is going to be a big challenge. So, yeah, it is very serious and it is very worrying. And I think it's possibly going to kill the internet as we know it, and there will have to be a rebuild around some new channels. And it will be very interesting to see who owns those channels and how they're managed. I think it's going to end up a lot more with state control, unfortunately, institutional control, and people are going to be turning again to things like the BBC, maybe as a trusted source of information. We'll have to see how it goes.
Very interesting. And I'd like to ask you a bit about sort of how AI can be combined with blockchain, or if you know of any use cases where AI has been sort of leveraged for a blockchain sort of use case or implementation.
So I think it all depends what you're talking about, because even the term blockchains become very fuzzy, and we see things like distributed ledgers, and there is quite a lot of excitement in the world about using the financial world about using distributed ledgers. The truth is that you can do a lot of the things that are done with distributed ledgers with a database and some people who you trust. But there are strong arguments around latency and cycle time and cost, and that you can have cheap, trustless infrastructures to work between organizations. So I think it's very much about, can you make your business case stack up and can you make it work? But it's not something I've ever been really heavily involved with, and I think it's very different from AI. I think it's AI is it tends to get lumped in. People like to talk about Web3, AI, biohacking, blockchain, all in one sentence as sort of representatives of out there technologies. Quantum is another one. People talk about quantum technology, right? And I think it's quite interesting that AI in the last, it's happened over 10 years, maybe a bit more. I did maybe it's about 12 years, 13 years. I remember I did a presentation at a big event in about 2012, I think it was, and I was the only person they could find from industry in the UK. It's not quite true. There was a from big industry, like, so there were people from startups, so there were people from DeepMind, there were people from universities, and then there was one person, a lovely person from Hewlett Packard, who was there, and that lady and I were the only people who the organisers could find in the UK to talk about using machine learning in business, right, in big business. And the lady from Hewlett Packard was actually incredibly academic person, right? She was really very theoretical and accomplished, and had an amazing publication record and for HB Labs, and I didn't, right? So I was the only person who was talking about nuts and bolts applications, and the organizers told me, we can't find anyone. We wouldn't have you, but we couldn't find anyone else. Thanks for that. uh, but nowadays, if that kind of event happened, there would be, thousands of people who they could find, hundreds of people certainly, and this is the revolution over the last 10 years, right? We've gone from heroic technology that was very difficult to use. It took a big feat of imagination to see how to apply it, and a lot of work, to now something which is a very useful tool for a lot of different situations. It's not as useful or as easily applied as some of the people on Twitter seem to think it is. But it's very simple to use ML to build an application nowadays, and that that's a massive change, and it really separates it from the other buzz technologies that you see. Quantum computing. It takes, people don't realize Google's Sycamore quantum computer, first of all, it can't be used to solve any actual real problem, right? It works. It's definitely a quantum computer, but it can't really be applied to a real problem in the real world. In the next few years, they will probably manage to get it to apply to a real world problem. But what people don't understand is that it takes them about 48 hours to turn the thing on and off, right? I mean, you can't just turn it on and run it. It takes about 48 hours for a team of people to get the thing to work, right? So not only isn't it able fundamentally to work on a real problem, it takes it when it is, it's going to take 2 days for it to be set up to do that. And that's not a practical technology. And it will be, at least a decade, probably 20, 30 years before that technology actually starts to make a commercial impact, in my opinion. I hope I'm wrong, but that's what I think. And I think a lot of these other things, it's going to take a lot longer than people think it is to actually get them into everyday use. Whereas in the last 10 years, AI, well, certainly machine learning has made that transition, and it's part of the economy now.
And if you were, now this is just like a fun thought experiment. If you were the CEO of a massive multi-billion-dollar AI company, what AI technology would you mandate be created by this company?
So I've sort of been gazumped on this, right? I'm quite annoyed about it. So um, I don't actually. I think it'll be quite interesting to see what happens. So my thesis for a bit has been that the first 30 or so years of work in AI was all about trying to find ways to tell computers what to do more efficiently. And it was sort of accepted that there was a limited amount of stuff that the computers could do, but the difficulty was getting them to do it. And then machine learning came along, and we kind of got over that problem by just showing the computers the data and saying, okay, now what will you do? What can you do now? So you now acquired some capability from this data. How can we use that, right? So there was a real shift between trying to program computers, and we realized that that was very, very difficult, and to allowing the computers to program themselves with machine learning, right, after a fashion. And I felt for a while that actually there's a lot of low hanging fruit in the telling computers what to do area, and especially because there's a whole load of latent capability in machine learning systems that we don't really use, because it's quite hard to express what it is that you want from it. And recently, so I've had this idea for a long time, and I have a paper I've been writing for years and years about this, but I haven't got anywhere with it. But my ideas are more formal than the mainstream ideas. But now people are doing this stuff with prompt engineering, and they're coming up with ways to instruct machine learning models to perform in ways that are unique, right, or interesting. And I think that's really interesting thing to do. So I would probably, if I had my head, I would be looking in that direction. If I was allowed to, I'd look in that direction. But I would do it somewhat differently from how the mainstream are doing it. But I think my case for it being an interesting thing is very eroded by all this mainstream interest in prompt engineering. So we'll have to see how well prompt engineering works out. But that's the really interesting area for me is trying to make sure that machine learning models do what we want them to do, rather than something approximately like that.
What is your view on ChatGPT and all of the doomsday sayers who say that ChatGPT is going to replace us all? Uh, or the other view, which is that it has very little to no impact. So I've heard sort of both things. So yeah, what's your
I mean I think it's very hard to know, and there's a very it's like when Chairman Mao was asked about the French Revolution. Has was the French Revolution successful? He said it's too early to say, right? And I think that it's far too early for us to know really what GPT is going to bring for sure. And one thing I would say is we've seen a lot of excitement over AI systems in previous years. So Jeopardy and Watson are big examples, and Deep Blue as another example. And I think sometimes it's very easy to overestimate and it's very easy to underestimate the impact of these things, and we will just have to see. I do find it amazing as a thing, right? It's certainly uh, it's certainly a surprise that it works as well as it does. Um, and I think it's a surprise that it has come to us as quickly as early as it has. I didn't expect anybody to spend $1 billion on building a thing like this anytime soon. And I think that huge investment of money has had a transformative impact. Um, and I think that is very surprising and startling, actually. Um, so I'm in between. I think that there will be a lot of valuable applications. There are obviously a lot of applications for this technology. Um, I think there will be a lot of near miss applications. I think there'll be a lot of disappointment that people can use it to do certain things, but it's not good enough to do others. And therefore, it won't quite get over the point of being valuable in a lot of situations. But I think it will be valuable in quite a few. Um, and I think there will, because of the way it's been released, I think there will be a lot of problems with it. So I think there have already been some nasty situations where people have used it for psychiatric health counselling, for instance. Um, and I wrote a paper about this, just a puff piece to share with clients. And I was saying about people using it who I know personally have been using it on dating profiles and this kind of thing. And then I watched South Park the other night, and South Park had gazumped me and beaten me to it, and they did a thing about ChatGTP being used for dating and for messaging people. And I think it's incredibly it's going to be incredibly painful in some scenarios like that, where people find out that the people that they thought they were talking to aren't the people they were talking to, but really they were talking to a robot. And that's going to hurt a lot of people, I think. And I think it was very irresponsible for it to be released in the way it has been released. I think that's the other thing I would say. It's out there now. There's nothing we can do about it. But I think it was irresponsible that it was just released. You know, it means that the adjustment has to happen very quickly, and all the consequences have to play out. And I think that a more controlled release process might have avoided a lot of harms.
And in terms of its limitations, I think we're running a bit low on time now.
Mm-hmm.
I think this is probably going to be my second or third last question. If you have time, do you?
Yeah, of
Okay.
course.
So, in terms of its limitations, what do you think are some of its limitations of ChatGPT? Because a lot of people have this idea that it can just answer anything, and I think, for example, have it cannot come up with anything new. For example, is a limitation.
Yes, so they did prevent it from connecting to the internet initially and looking up stuff. I think that Bard, the Google version, can and does. So that's not an intrinsic limitation. It's something they put on it to control it somewhat, to control the kind of thing it produces. I think that the models themselves, it seems that they have a problem with abstractions and world models. So you can, because they are predicting the outcome of puzzles based on training that they've had in the past, rather than actually dealing with the abstractions and processing the abstractions and coming up with an answer. You can see sometimes that they fail because of that, that their reading of Reddit leaves them with an answer that looks right but is wrong. Okay. And so I've had a bunch of examples I've found where you can trick it with number puzzles that anybody should get right. Sometimes it's been shown to make mistakes just counting numbers of balloons, right? There's a mistake that Rodney Brooks has documented there. The problem is that OpenAI have taken the policy of reading about mistakes and then explicitly correcting the model. And so this is leaving the impression that all of these problems have been patched, whereas the fundamental weakness of the reasoner is that it's predicting an answer rather than processing an answer and coming to an answer. Now, we get into deep water because some people think that humans work that way as well. And they will point to a lot of psychological experiments which show that humans don't work rationally and don't do rational processing. And therefore, they'll say, well, ChatGPT is behaving just like humans. And there's a deeper sort of philosophical position that some people have come up with, which is called distributional semantics, they call it. And what they're saying is that meaning actually arises from the pattern of words and from the way that words are used, right? Rather than the human beings being the grounding of the meaning and having meaning grounded through their experience in the world. And again, it's very hard to argue with it because we don't have access to the insides of human thought processes, and we have all this evidence of correlation between token distribution and meaning, right? But it's nonsense, right? And I think that that lack of a understanding of the world and a lack of agency is what will fundamentally limit the usage of the large language models. And I suspect that we're going to find this technology very valuable, very useful, possibly revolutionary, but very useful. Clearly it is. But I think in 5 years, we'll be still looking for the next big thing.
And this brings me to my last two questions. What is one of the most mind-boggling life experiences you've had in terms of traveling, seeing a landmark, etc.? And the last question is, what do you think is the purpose of life?
So mind-boggling experiences are all to do with mountains for me, in traveling, that is. So always to see amazing places and go on adventures when I was younger, and I'll always remember those experiences. Climbing in the Coolins in the winter, and actually, I was watching David Attenborough the other night, and they had a drone shot of going over a mountain, and I knew exactly where it was. It was Ashbarfrith in Ambarfrith in the Coolins in Skye, and it was over the ridge and looking down. And because I've climbed up there in those conditions and looked down and seen eagles flying around beneath me, and it was amazing. It was amazing. So I miss being 20 and doing that kind of thing. And the meaning of life is other people. So this is the other side. So, the meaning of life is to be with your family, my wife and my daughter, and my mother, my brother, my sister. That's the meaning of life, right? That's the important things. So we don't really have a purpose, though. We're just little creatures, and I think the only good thing to do, the only worthwhile thing to do, is to try and find another little creature to hug. Right? That's the only really important thing you can do in your life.
That was incredible, Simon. Honestly, I had a great time listening to your experiences, and also I think it's a great reason to buy your book. You mentioned quite a few things about that as well, and
I don't think I
how...
mentioned enough. Actually, I think there's more. I'd like to do more sales pitches for it.
Well, yeah, you can come here anytime you'd like to promote your book. And hopefully I'll see you next time one day.
Yep, looking forward to it. Give me a call.
Thank you.
What a pleasure. See you soon. Bye-bye.
Goodbye. Thank you for coming on the show. This was the Intrastellar podcast with Shoaib Hussain. Please like, share, and subscribe, and click the notification button. Thank you for watching, and I look forward to seeing you again.